Good morning. I'm going to do a brief explanation of my project of the crime scene investigation. So first of all, we're going to measure the width and the length of the blood spatter. When we do the measurements, make sure we don't calculate anything from the tail of the blood spatter because it's from the impact. We try to measure the length of and the width of the original blood spatter only. And after we do that, we will see this first triangle right here. This is the angle of impact. This is the length of a blood spatter and the width of a blood spatter. So what calculation we will use is because sine theta, this is the angle of impact, it's width over length. So in order to get the theta angle, we would do arc sine of the width over length, which is similar to the calculation right here. So arc sine of the width and the length over the length, and we get the angle, which is right here, the angle of impact. After we got that, we will look at the blood spatter right here. So this is the dashed line is the distance from the convergence, and this is the height of from the impact of convergence, and this is the actual length from the impact of convergence to the blood spatter. So if we get this triangle, this should be perpendicular to the ground here because it's the height. So if we get the triangle right here, this one, and we will see the triangle right here. So this the height and the distance are the two sides, and this should be a right angle right here. So this is also the angle of impact, the same angle. So we already know this angle from the calculation up there. So what we will do is we already measure the distance of the blood spatter, and we can estimate the height of from the impact of convergence to the ground. So we can actually get the height and estimate the height of the criminal. So to do that, we already know the distance, and we already know the angle. So what we'll do, we'll use tangent of this angle, which means it's height over distance, and then times the distance. So we will know the actual value of the height. So that's the calculation right here. The angle is 45.1 degrees for the first blood spatter. The distance 4.1 feet. So what we'll do, just tangent this angle we got from the top, and then times to the actual distance, and then we get the height of the impact of convergence, and this is the formula right there. And to determine whether the bullet was pointing upwards and downwards is kind of hard to say, but when we look at the formula right here, the height of the impact should remain the same. So the longer distance, this is if we look at here, the longer the distance traveled, like the blood spatter distance traveled, the smaller, if we draw actual triangle here, so the longer the distance traveled, the smaller the angle of impact would be. So we can think about the distance from area of convergence and compare it to the angle. So the smaller the angle, it means the blood spatter traveled longer. So to travel longer, it actually needs the bullet to shoot upwards so it can fly further away. If we do a force impact of the blood spatter after coming out from the human body, this if the bullet was going upwards, so the blood spatter will go out, the blood drop will go out pointing upwards as well. So this is the initial velocity of it, and this is the resistance of the air, and then there's just gravity. So if we separate the force of like the velocity of the initial velocity, we get a velocity pointing sideways, which is which can show the travel distance, and force pointing upwards, so it got contradicted by the gravity, and there's a resistance from the air as well. So the longer it travels, because of the resistance, the smaller the velocity would be, and it will finally like fly down, because there's gravity contradicting the velocity pointing upwards as well. So at the end it will drop on the floor. So when the bullet is going up, the blood spatter will fly further away and get a smaller angle when it because of the triangle right here we just got. And if the bullet was shooting down, which means the initial velocity is pointing downwards, and we can get we can separate the velocity into downwards and sideways, and we get gravity as well here, and we get the resistance up there. But so the longer it flies, the velocity will get smaller and smaller, but it will get faster and faster to drop on the ground, because there's gravity and the velocity pointing downwards. So if after the blood drop comes out from the victim, it will just shoot straight on the ground. And in this case, the angle will be larger, and because the distance the blood drop travels is shorter. And to determine the height of the killer, we have to judge like depending on the angle of impact and the height of the impact of convergence happened. We can like assume like how tall is the killer, but it's not definite. We have to try to see what posture, like what was the scenario, how did the assume like how did the killer kill the victim, in what posture, what height, and pointing at what area of the victim to shoot him. And this concludes my explanation of the crime scene investigation project.